Yeah, you need to take well,
Well, it's not next week, that's week.
Oh, we have a holiday next week.
That Monday. Let's move to the program.
Four days.
All right. So today, near the end of class, I'm going to be checking a couple of things. I'll be checking your worksheet 2, which we're going to just go through. Well, I'm going to have you guys work on the problems a little more independently, but I'm still going to go through the answers with you. And also, I'm going to be checking your packet, page 3 through 12, by the end of class. Okay, so that'll be for class. That'll be for class credit. Right. Well, I know we skipped a couple problems. We didn't do every problem in pages 3 through 12, but I'm just going to be checking for the ones that we did together as a class, either in person or virtually last week. Okay, so you guys just picked up worksheet 2. Go ahead and look at number 1 and see if you can decide how you want to start this problem. Okay, so let's look at number 1 there. And if you're moving faster than the pace that I'm going, you can always check your answers with my website, because I uploaded the second worksheet's key on the website, so you can go at your own pace if you're going faster than me. Okay, so first things first, you're really just going to take care of the multiplication, right? So I would multiply the 2 through first, and then look at the dimensions and see if you can find a way to get your 2 matrices resolved there. Now, when you multiply the 2 through, the 2 is only going to be multiplied with the first matrix. You're not going to distribute the 2 through the second matrix. Okay, so it's only going to be with the first matrix. Okay, are these 2 matrices, are these 2 dimensions compatible? Yes. 2 by 3, followed by 3 by 2. Right. This matrix is 2 rows, 3 columns. The second matrix is 3 rows, 2 columns. As long as your inside matrix dimensions are alike, you know you can move forward, and then your resulting matrix is going to be a 2 by 2. Okay. We're just going to focus on the multiplication portion of this. we're left with a 2 by 2 matrix, right? So for each of the elements, you're going to be, for the first matrix, you're going to go from left to right. And for the second matrix, you're going to go from top to bottom. You're going to pair up each number with a partner. Okay, so 10 goes with 1, 2 goes with 7, 8 goes with 8. Okay. Repeat the process to figure out the values for each of the other elements. All right. This is located second row, first column. So you're going to be pairing these numbers together. Okay. Okay. This space is first row, second column. Okay, for now, you can, if you want to use the calculator, you can. Tomorrow, the numbers will be easier. There are no calculators tomorrow on the quiz, okay, because the numbers will be easier. But I know right now, the numbers that I chose for this worksheet are a little bit large. So this whole multiplication process will leave you with a 2 by 2 matrix. And now we can go back and figure out what the resulting subtraction is between these two matrices, right? 2 by 2 matrix minus this 2 by 2 matrix. Okay, any questions with number 1? Okay, take a look at number 2. Look at the dimensions. Are we able to subtract these two matrices together? Yes, right. These are both 2 by 3 matrices. You just have to resolve the 2, multiply the 2 through, and multiply the 4 through. Yes.
How do you know it was an even up mode?
So there are two ways you can do this. If you multiply by -4, you can do that. But if you multiply by -4, then you got to change this operation to be a positive. Right. Otherwise, if you multiply by -4 and you put a negative out there, then you're canceling each other out. So there's two ways you can do it. Either multiply by 4 and then subtract later, or multiply by -4 and then add the two matrices together. Okay, any questions with number 2? Okay. Okay, take a look at 3. Can we subtract those two matrices together? Okay, what's wrong with 3? Yeah, dimensions are not the same. You can multiply two matrices that are not the same dimensions as long as the inner dimensions are the same, but with addition subtraction, it's very straightforward. It's got to match exactly with the same dimensions. Yes. Yeah. It's also on my website too, but yeah, see if you can access it from there. Okay. What about number 4? Okay, what's wrong with 4? Yeah, inner dimensions have to be exactly alike. If they're not alike, then I can't go any further, right? So this first matrix is a 1 row by 5 columns. The second matrix is a 6 row by 1 column. The middle numbers have to match. If the middle number matches, we can take the outside numbers as the new dimension. But if those don't match, we just have to indicate the reason why. Okay. The inner dimensions do not match. Yes.
How is number 3 not possible?
Because we're subtracting them. If we're multiplying them, then yes.
Oh.
Number 3 is possible. But if you're subtracting them, then if I'm adding and subtracting, I'm always going to be ending up with the same dimensions. Yeah. Okay, look at number 5. What would you do first with number 5? Okay, where does the 2 go? Just the first matrix. Okay, you're not going to look at this. It's just going to multiply through one of the matrices. Okay, so just always do the first. Just do the one that is next to it. Okay, once you distribute that 2 through, then you're staring at two matrices that don't have the same dimensions. but we can see if they can be multiplied together, right? So are these two dimensions compatible? Yes. 2 by 2 with a 2 by 4. The inside numbers matches. So we know that we're going to end up with a 2 by 4 matrix. Go ahead and fill out the rest of those spaces, clean those up, and you should end up with a 2 by 4 matrix. Okay, any questions so far? Yes.
When you're multiplying them across, would you multiply them all by -2 over 2, or would you alternate? Like right here, if you multiply these, -2 over 2 this row.
So which are you trying to fill out this space right here? Okay, so you're trying to fill out this space. You see how this is first row, second column? So you're going to be using these numbers to get the rest space. So it's going to be go from left to right on the bottom. So 2 times -1 and -2 times 7.
Thank you.
So it should get you -16. Okay, thank you. So I like to space out my second matrix so that I can give myself a lot of space to total my values together. It helps the second matrix, space it out. But you don't have to, just it can help you see where those pieces go. Question?
So it doesn't really matter which number you think is right.
No, it doesn't matter. As long as you're pairing the right numbers together and that you're adding the products together. So. But if your answer doesn't quite match mine, then that's an issue. So, you know, your order of the pairing of numbers may be different, but it needs to at least match my answer. So just make sure that's good. If that's good, then your process is correct. Any questions with page 1? Okay, page 2. Number 6 and 7 says, determine if matrices A and B are inverses of each other. So here's a relationship. If I'm looking at two matrices and if I want to know whether they are inverses of each other, that means they're going to multiply together to create basically a canceling out of the two matrices. So the canceled out version of two matrices looks like that identity matrix, looks like that 1, 0, 0, 1. It's basically two matrices kind of undoing and canceling each other out. This is basically the matrix version of quote unquote 1. Okay, it's like multiplying 3 times 1/3 or 4 times 1/4. It's a so if I can get two matrices to multiply to be 1, 0, 0, 1, I know that I can backtrack and say A and B must be inverses, right? But if they don't multiply to be 1, 0, 0, 1, that means they're not quite having that relationship in terms of inverses. So if it equals that, then you know they're inverses. If it doesn't equal that, then they're not inverses. Okay, so the way to tell is just multiply the two matrices together and see what 2x2 matrix you get. Okay, so try that. You know you're going to end up with a 2x2 matrix because the dimensions are the same, the inner dimensions are the same, and then the outer dimension is 2x2. Okay, so are matrix A and B inverses of each other? They're not. Okay. Show the work and explain why. Okay, number 7 and 8, what do those notations mean? They're asking you to find the what? Just determinant. Yep, so just AD minus BC. You're just going to find a number, right? Numeric value for 7 and 8. 7 and 8 are both notations that indicate asking you to find the determinant for that matrix. Just the determinant, okay? Are we okay with 6? All right, try 7 and 8. So DET means find the determinant, and then also if you see the vertical bars, that's also indication for you to find the determinant. Okay. Just basically subtract the diagonals. A times D minus B times C. Okay. Check your answers for 7 and 8. Okay. Are we okay with 7 and 8? Okay, so now moving on to 9 through 11. Now these are asking you to find the full inverse of the following matrices. So as a reminder, here are the steps to find the full inverse of a matrix. Okay, so let's say you start off with matrix A, B, C, D. What you're going to do is you're going to find the determinant first, just like how we did with 7 and 8. 7 and 8. I'll come out to be a number, right? AD minus BC. Whatever that number is, that's going to go in the denominator of the fractional value outside of your inverse. And if you're starting off with matrix A, B, C, D, you're going to have to do some rearranging to create the matrix that's required of your inverse matrix. So what you need to do is, after you do 1 over determinant, you got to play around with these values. You got to change some values around. You're going to take the first the diagonal from the top left corner, and you're going to swap these two values. So the A and D will swap out to be D and A. Okay. Don't change the signs. You're just going to pick those numbers up and make them swap places. Okay. And then once you do that, you're going to have to make some adjustment with the other diagonal as well. The other diagonal, you're not going to change signs. Sorry, you're not going to change places. You're just going to change their signs. So the negative B and negative C, it doesn't mean that these are always negative. It just means that these are always the opposite of the original signs. That's what the negative B and negative C means. And once you have all this in front of you, then you're just going to multiply and distribute this fraction through each of the elements. Okay, so let's try number 9. Okay, determinant first. Negative 4 plus 10 is 6. Now we're just going to follow the formula for your determinant. Make sure you put that determinant in the denominator of your fraction. And then rearrange and change the signs according to this formula, right? So swap the first diagonal out, swap places with those values. And then the other diagonal, change their signs. -5 becomes +5, 2 becomes -2. And now you're just going to multiply that 1/6 for every element, every one of the 4 elements that you see. Okay, reduce if you can. Okay, any questions with 9? So what situation would an inverse not be possible? Yeah, if your determinant is 0, then that means you're sitting at, that means your matrix is singular. No inverse is going to be possible because I can't stick a 0 in this space, right? I can't put it in a denominator. So you would just say determinant is 0, therefore inverse would not exist, okay? But that's only if determinant is 0. If it's any other value, then you're going to be able to find an inverse. Okay, any questions with 9? Okay, try number 10. Okay, let's check our answers for answer for number 10. All right, no questions with 10. Okay, here's 11. Not on the quiz. It'll be on the test, but not on this quiz. Okay, any questions with 11? Okay, so number 12. Number 12 says, find the value for the missing element that would make matrix F singular. So singular means that an inverse does not exist. So what will ensure that the inverse does not exist? If determinant is what? 0. So we're going to force a situation that allows that determinant to be 0. So we'll just set up our determinant formula, and we'll do AD minus BC, and set that equal to 0, and see if we can use that to help us solve for X. Try that. So if I try AD minus BC, I'll get negative 3 times 4 minus a negative 8 times X. I'm left with negative 12 plus 8X equals 0, and now I'm just solving my equation to try to solve for X.
Do we have to solve it like an equation?
Yeah. That's the cleanest way to do it. Otherwise, you're just having to go through guess and check, and that's not as efficient, right?
Well, 4 is half of it.
What's X going to be equal to? 0 or 2, right? So sometimes it may not end up being a nice whole number. It may have to be a fractional value in order for that AD minus BC to work out to be 0. So we just make our equation do that work for us. Okay, any questions? Okay, I'll try to put together another review worksheet for tomorrow. If you want to come for a help session during one of the lunches, you can. I'm also going to try to upload it so that if you want to get that extra practice worksheet, you'll be able to do it at home tonight. Okay. Okay, any questions with this worksheet? This is what your quiz will look like. All right, let me come around, and if you guys can just flip through your packet. I just want to see pages 3 through 12.
Okay, I think I did it in
This one.
packet. I'll go and
Okay,
get the other one.
thank you.
That's
Yeah, I'll try this.